Hi, everyone. This is Ms. Flores. I want to talk to you today about finding the area of regular polygons. If you look at what's in front of me here, you'll see that I have directions to find the area of the regular polygons on the page. And the first one that's shown here is a nonagon with a side length of 9 centimeters. Well, my knee-jerk reaction is that this seems really hard. I just know that what side length is, and right, side length, I need to know where that is. I'm talking about any of these congruent sides because the shape is regular, right? I know that I have a center since it's a regular polygon, and the side length is 9, so I understand that information there. My next step is really to go back to what our class was understanding last week or in our previous class experiences about isosceles triangles, right? So I'm going to just take a side step over here really quick while we talk about an isosceles triangle. If I can draw one, that would be great, right? Now, from last week, our isosceles triangle understanding was that I could find the area of this because I understood that isosceles triangles have a line of symmetry that bisects that single angle and bisects their base such that this line of symmetry is perpendicular and is the height. So if I understood an angle in my isosceles and I understand how the line of symmetry bisects, I could find the area of this isosceles triangle because this is the base, I have a height, and I could use my area formula for a triangle, where area of a triangle equals 1/2 base times height. And I could do that using trigonometry. So I'm going to use this information and now apply it to my regular nonagon. Okay, so the thing is, we know that regular polygons are the result of taking an isosceles triangle, and I create 2 radii, right, from the center, and reflecting it around. So if I have a nonagon, which means I have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, that means there are 9 of these congruent isosceles triangles. So if I can find the area of one of them, that gives me an access point into finding the area of the total figure. Okay, so what I'm going to do is I'm going to take this isosceles triangle and I'm going to draw it out over here. Right, so I'm going to take this and I'm just going to catapult it there. So these become radii, right? This becomes a side length, which we know is 9 centimeters. And what I need to find, because I know these are congruent, right? This is my isosceles triangle that I want to find the area of. But the area that we were practicing previously was that I understood this angle right here. And this angle is this angle here. And looking at that regular polygon, that is the central angle. So if that's the central angle, I need to be able to calculate that. And as we have previously gone over, the central angle is always equal to 360 divided by the number of sides. Well, in nonagon, there are 9 sides. I'm going to put that up here, 9 sides. So I divide it by 9. And in this case, I get 40 degrees. So that entire angle is 40 degrees, right? But now that I know that, I'm just going to mark it over here so that way it's clear. It's 40 degrees. If I want to find the area of that figure, of that isosceles triangle, I'm going to have to bisect it, right? Coming back to my isosceles triangle here, I'm going to have to cut it in half so I can figure out what this height is, right? So I'm going to cut it in half. And when I do that and I apply it over here, what I notice is what I'm really applying, because it's perpendicular, what is my height is also my apothem, which is kind of interesting. So my apothem, or I should say apothem, is the same as the height, right, of my isosceles triangle. So when I cut it in half, remember that bisects the base. So I'm going to separate it out. So this is really 4.5 because 9 divided by 2 is 4.5. I want to figure out what this height is, which is really my apothem. And this angle also got bisected. So 40 got divided in half, and I get 20 degrees. And so now I'm able, right, since this is my little h here, I am able to calculate what that is using trigonometry, which is what we talked about when we went over isosceles triangle area. So I can say, great, well, looking at that 20-degree angle, here's opposite, this is adjacent. I'm really talking about tangent, okay? So the tangent of 20 degrees is 4.5 over my height of my isosceles triangle. Now again, we have h on the bottom. So the first thing we do is we want to do the reciprocal. So I get 1 over the tangent of 20 equals h over 4.5. Right? Now that my h is on the top, I can multiply the whole thing by 4.5. And I get 4.5 divided by the tangent of 20 degrees is equal to h. And again, when I do that, and I'm using my calculator, right? 4.5 divided by the tangent of 20 degrees, make sure your calculator is set in degrees. I get a crazy decimal. And this is where you have a choice. Do you want to play with your area with an exact answer or with a crazy decimal? The choice is yours. I'm going to choose the crazy decimal. But when I do that, I want to make sure I go to 4 place values. Because, right, this is where I'm going to be doing a lot of different problems. So I have 4 decimals here. I now have the height of this isosceles triangle. So I can go back now and I can say, great, right? I have the height, I'm good. All that work is related to the blue. So now the area of my triangle, and I like to keep my areas really clear because I'm not just focused on the area of a triangle, I'm trying to find the area of the entire shape. So the area of the triangle is 1/2, and what's the base? My base is actually 9, times the height, which is 12.3636. And I want to put that in my calculator, right? I want to be able to calculate the area of that triangle. So when I do that, I can simply do 9 times 12.3636 divided by 2. And the area of my triangle is about 55.6362. I'm not worried about my units yet because I'm not done. I have found the area of one triangle. My goal was to find the area of the entire figure. And this is where I need to understand what a nonagon is. A nonagon is a 9-sided polygon. I have found the area of one of the isosceles triangles. But in reality, the number of isosceles triangles is equal to the number of sides. So there are 9 isosceles triangles in this regular polygon. So the area of my total is 9 times the area of one of those. And now I can type that into my calculator. So I take that answer, right? And I want to times it by 9. And the area of my nonagon, or the area of the total, is roughly, right? I can say this is about 500.7258. And this is where I care about my units. My label is centimeters, so it is centimeters squared. And there I am, right? So this is really, when we're looking at this, right, understanding that you're going to first need to understand some part of your isosceles triangle and calculate some element. Sometimes one element, sometimes 2 elements, it really just depends. Once you figure that out, you can then apply it to a single triangle. And once you have the area of that single triangle, apply it to the total triangles in the figure.